Hello, this is the section 7.2 lesson. In this section we're going to talk about two techniques for solving ratio problems. One technique we've seen before, another technique is going to be something new. So to illustrate the first technique, let's look at this example. A punch recipe is made by mixing fruit juice and soda in a ratio of 5 to 2. So you've got this ratio here of 5 to 2. Now no units are given, but as we saw in section 7.1, it doesn't matter what the units are. It could be anything as long as the units on both the fruit juice and the soda are the same. So it says if you have 2 cups of juice, how much soda will you need? And then how much punch will you make? So we need to know the amount of soda and the amount of punch. And so to solve this ratio table, we're going to have 3 rows, one for the juice, one for the soda, one for the total. And so let's put our original ratio of 5 to 2. Let's use units of cups here because that's what was given in the question. And so if we have 5 cups of juice, 2 cups of soda, we're going to make 7 total cups of punch. And now it says we only have 2 cups of juice. So that means we want a 2 here in this first row. But to go from a 5 to a 2, we're going to have to multiply by a somewhat nasty fraction. I don't want to do that. So let's put a 2 over here, and let's put an intermediate step of 1. And so to go from a 5 to a 1, that's pretty simple. We're just going to multiply by 1/5. 1/5 isn't too bad of a fraction. So 2 times 1/5 is going to be 2/5. 7 times 1/5 is going to be 7/5. And now to go from a 1 to a 2, let's multiply by 2. 2/5 times 2 is 4/5. 7/5 times 2 is 14/5. And so there's the answer to our problem. We're going to need 4/5 cups of soda, and that's going to make a total of 14/5 cups of punch. Let's look at a slight variation of this. Same scenario of a ratio of 5 to 2, but now suppose that we want to make 4 cups of punch. How much juice and soda will you need? So let's put our original ratio of 5 to 2, which will make a total of 7 cups of punch. Now we want a 4 in this last row, but to go from a 7 to 4 we'd have to use a nasty fraction, so let's put a 4 over here and an intermediate step of 1. So to go from a 7 to 1, let's multiply by 1/7. 2 times 1/7 is 2/7, and 5 times 1/7 is 5/7. And now to go from a 1 to a 4, let's multiply by 4. 2/7 times 4 is 8/7. 5/7 times 4 is 20/7. And so there's our answer. We're going to need 20/7 cups of juice and 8/7 cups of soda, and that'll make a total of 4 cups of punch. This technique that we're using here is called going through 1. It's a technique of simplifying the problem of working with fractions, so we don't have to use a nasty fraction, we can use a simpler fraction. Let's look at another example. This example is not going to use a going through 1, but it's going to show an interesting use of ratios. For next semester, 4 times as many sophomores as freshmen registered for Math 201. If 20 students total registered for the class, how many sophomores and how many freshmen registered? Now at first glance it doesn't look like there's a ratio involved here, but if we look closer we see that we've got 4 times as many sophomores as freshmen. So that means the ratio of sophomores to freshmen is 4 to 1. So let's set up a little table here, and so for just to start off things, let's suppose that we have a total of 1 freshman register for the class. Now that's not what's told in the problem, but let's start setting this up. So if we have just 1 freshman registered, that means we're going to have 4 sophomores registered, which means that would have a total of 5 students. Now the problem says we don't have a total of 5 students, we have a total of 20 students. And so we need to put a 20 here in our next column. So to go from a 5 to a 20 we need to multiply by 4. And so 4 times 4 is 16, 1 times 4 is 4. And so there's the answer. We'd have 4 freshmen and 16 sophomores registered for a total of 20. Now our last example is going to be completely different than these other two examples. We're not going to use a ratio table here at all. We're going to use pictures. So the ratio of Anna's dolls to Mary's dolls was 7 to 3. After Anna gives 6 dolls to Mary, both girls have the same number of dolls. How many dolls did each girl have at first? Now this problem looks completely different from the ones we've seen before, and so we're going to use a different technique here. So look at what we're given here. We've got this ratio of 7 to 3. Anna gives 6 dolls to Mary. Both girls have the same number of dolls. How many dolls did each girl have at first? So to set this up, we're going to draw a picture here, much like what we did in section 7.1. We're going to draw 7 boxes here to represent Anna's dolls, and then 3 boxes here to represent Mary's dolls. And each one of those boxes represents a group of dolls. Now I don't know how many dolls are in that group right now. That's what we need to really figure out. So we're told that Anna gives 6 dolls to Mary, and now they have the same number of dolls. So notice here that Anna has 4 groups more than Mary. So if Anna is going to give some to Mary so that they have the same number, that means Anna is going to have to give these last 2 boxes down here to Mary. And so let's draw that. Let's take these 2 boxes here, move them down to Mary, and make Mary's bar a little longer. So let's add 2 boxes there to Mary and cross off these boxes for Anna. And so now the girls have the same number of dolls. So let's try to figure out how many dolls was in each group. Well, Anna gave 2 dolls to Mary, or 2 groups of dolls to Mary, and those dolls total 6 dolls. So we have the 2 groups of dolls equals a total of 6 dolls. And so that means that, well, one group is going to equal 3 dolls. And so now we know how many dolls are in each one of those boxes or in each one of those groups. And so now how many dolls did each girl have at first? Well, at first Anna had 7 groups. So Anna has 7 groups of 3. So 7 times 3 is going to be 21. That's her total number of dolls. And then Mary, well, she had 3 groups of 3, and that's going to be a total of 9 dolls. And so there's our problem. Anna had 21 dolls and Mary had 9 dolls.